So introduction to quadratic functions. This is what we're working with for sections 5 and section 6. So learn to love the word quadratics. It's not going away. All right. So a quadratic function as an equation. Oops. I did not want that to happen. Hang on. Okay. Okay, as an equation, a quadratic function is a polynomial with a degree of 2. Okay, so that's what we were talking about when we're talking about a degree or a polynomial. That just means that your exponent on your variable has a degree of 2, is a 2. Okay, so that's all a quadratic function is. We've seen plenty of them so far this year. But now we need to learn how to solve quadratic functions and what they mean in the real world. So I gave you an example. This is the parent function of a quadratic function. If you're looking at the parent function here, you'll notice there is not a b or a c term. Okay, so that's just a parent function. And that'll matter when we get into section 6 more so than right now. A standard form of a quadratic function is when you have f of x equals, remember f of x just is the same thing as y, okay, equals ax squared, so we're going to have our a term, plus bx, which is your middle term, like we just found in our perfect square trinomials that we did, and then our c term. Okay, when we have an quadratic function in standard form, our a term tells us if it's positive or negative. And our c term tells us the y-intercept. So our y-intercept is always where our x is equal to 0, and then we have a y term, so that c term for our y-intercept is the same as our constant in our standard form equation. Okay? You will sometimes have just a quadratic function in a table. They won't give you the equation, and they're not going to give you a graph. They're going to ask you to identify a quadratic function from a table. In order to do this, right, you're going to have to determine if you have the same second difference. Well, that didn't work. And what I mean by second difference is this number right here. So if you found the first difference, meaning how much your y is changing, okay, these are your y values. So you look to see how much your y values are changing. And you can see in that first row, that's your first difference, they're all different. But if you go to find the second difference, that's this right here, this is your second difference. If those are the same, then you have a quadratic function. So let's look at this table and determine if this is a quadratic function or not. So we're only looking at our y values. Oops, I don't know why it did that. Okay, we're only looking at our y values here, and we need to determine if this is a quadratic function or not by looking at the second difference. So how do I go from 6 to 0? I subtracted 6. How about from 0 to -4?
Subtract 4.
Subtract 4. from 4 to negative 6?
Subtract 2.
Subtract
2.
2. Yep. Negative 6 to 6
Add 0.
is
No.
0. Negative 6 to negative 4,
Add
Add
2.
2.
add 2. Negative 4 to 0,
Add
4.
4.
add 4. And then 0 to 6,
Add
6. Add
6.
6.
we added 6. Now we're going to look at our second difference, because obviously none of those first differences are the same. They're all different. So we look at our second difference. How did I go from negative 6 to negative 4?
You subtracted 2.
Plus 2.
Plus 2.
Negative 4 to negative 2.
You added 2.
I added 2 again. Negative 2 to 0.
Add 2.
Add 2. Do we see a pattern here?
Yes.
Yes.
So do we have the same second
You
difference?
add stuff.
So this here is my second difference. And because it's the same, I have a quadratic function. All right. So that's how you tell by a table if you have a quadratic function. You're looking at the second difference. Now, a graph of a quadratic function, which is primarily section 6, but it's important for us to understand what it looks like now. Okay. A graph of a quadratic function, it's called a parabola. Or as some students say, parabola. But that's not the correct way. It's parabola. Okay, so if the a term of your quadratic function is positive, then your quadratic function is going to open up like this. Okay, so a parabola looks like this or like this. And if it's a positive, if your a term is positive, then your function will open up. If your a term of your function is blank, it's going to open down. What word do you think goes there?
Negative.
Negative. So if the a term of the function is negative, it's going to open down. Okay, so again, I just gave you the standard form equation here again. So for an example, if we had f of x is equal to 2x squared, this number right here is telling me that it's going to open up because it's a positive number, or your a is greater than 0, so it opens upward. Now, if your function has a negative with your x squared, then it's considered less than 0, and it opens downward. So your a either has to be greater than 0 or less than 0. If your a was 0, then you wouldn't have a quadratic function, just saying. All right, are we good here? I will post a picture of the notes, and I am recording, but are you ready for me to move on to the big graph?
Yes.
All right, so I'm going to move on.
Yes.
So if, oops, you are not able to print, it's okay. All I want you to do is draw a coordinate plane. I'm going to zoom out a little bit, give you a great idea of what to draw.
Can I be back?
So you're going to draw a coordinate, meaning two straight lines like this, right?
Miss Shagwe,
Yes.
can I go to the bathroom?
Yeah. Okay. Then you're just going to draw a parabola. And it doesn't have to be perfect. It doesn't have to look exactly like the one we have here. Just as long as it, in general, looks like a parabola or upside down U, it's crossing the x-axis at some point, right? That's all you need to take your notes on graphing a quadratic. So just by looking at the big quadratic function that we have, what type of function is it? Positive or negative?
Negative. Negative.
Negative, because it opens down. So up here in this top box, I'm going to write negative. Okay, because this function is a negative function. Now, when you have a negative function, your vertex is telling you the maximum. Okay, so this right here is telling you the maximum point of your quadratic function. So I want you to think of somebody standing on a balcony and throwing a ball up in the air. This is the type of shape that it's going to create. So this vertex is the highest point. The x value of your vertex is going to tell you the amount of time it takes to reach the max height. Okay, so that's what the x value of your maximum point tells you. So say that this point, I'm going to give you an example, was where my x is 2, my y is 8. So my x value would be the 2. So 2 seconds. Until it reached its maximum height. The y value is telling you the max height of the object. So that's the y value in the ordered pair, tells you the actual max height of that object. And I'm just supplying numbers there. This graph didn't have numbers, but I just wanted to give an example of what those numbers would look like. Okay. Next, we're going to talk about our y-intercept. What color do I want to use? I'm just going to use this. Okay. Our y-intercept is telling us our initial value, or our starting point, or our starting height. So we'll put starting point first. Can also be called the initial value. Now, if this point here, my x is 0, right? My y, I could estimate to be 6. So 0, 6. And the key point when you have a y-intercept is where your x is 0. Then we have a line going through our quadratic function, this thing right here, that dotted line. We're going to label that right here. Okay. This is called your axis of symmetry. And that's a vertical line that passes through your axis. I mean, passes through your vertex. That's what I meant. So that's a vertical line that passes through the vertex. To find your axis of symmetry, you're going to do x is equal to negative b over 2a. Okay, so this is your x. Right, and if we look back at our notes from our standard function, our negative b is right here, and then our a term is what we're talking about here. So that's the equation to find your axis of symmetry, where your vertex would be, of your quadratic function. I'm going to finish highlighting this. My computer's being all kinds of funky. All right. So that's the axis of symmetry. Looking over here real quick at this box, what type of function do I have? Positive or negative?
Positive.
It's a positive function. When I have a positive function, meaning it opens upward, I don't have a maximum. Instead, I'm going to have a minimum. This point right here is my minimum, my vertex. So my vertex of a positive function is the minimum, and the vertex of a negative function is my maximum. Okay, that's something to keep in mind, because sometimes they'll give you a quadratic function or say, what is the minimum or what is the maximum? Be careful that you understand which goes with which. Maximum goes with negative functions, minimum goes with positive functions. And that should be pretty easy to remember, because if you're opening up, you wouldn't have a maximum, because those lines are going to continue on forever. Okay? So remember, minimum goes with positive, maximum goes with negative. All right, almost done. Now we need to worry about these 2 points right here. Okay? These points have many, many names. Not many, but at least 4 names. And they can be referred to as your solutions. your x-intercepts, your zeros, and your roots. All of them mean the same thing. Solutions, x-intercept, zeros, and roots. Those 4 words are used interchangeably, and really what they're wanting to find is the solution to your function. Okay? So in this graph, we have a negative x value and a positive x value. So I'm going to go ahead and label these points. Okay, so this is when my x, say, is equal to 4 and my y is 0. And this here is when my x is equal to negative 2 and my y is 0. Again, always in xy form. So my negative value is negative 2, 0. And this is usually an invalid answer when it's talking about height or measurements. So I usually put not valid if dealing with time or measuring. With time or length. Okay. And your x-intercept is where your y equals 0. Now your positive x value, that's telling you when the object hits the ground. Or how long it takes. How long is the object in the air? So this would be 4 seconds. Again, this is your y is equal to 0. So your x-intercepts are always going to have y is equal to 0. So if you're given points, right, if we looked back at those tables, if there was a point where your y was equal to 0, then you would know that that's your x-intercept. Okay, your y or your output is equal to 0. All right, so those are your introduction to quadratics notes. Tomorrow for class, you're going to be doing a forms assignment for classwork, and you're going to be answering questions about the notes you took today. Okay, just identifying key features of the quadratic function. So that is it. I'm going to take a screenshot and post this to make sure you guys have it. But once you turn in your assignment, which you should be able to take a picture of your notes and turn it in now, then you are free to leave the meeting. All right, you should use the next 5 minutes. We have 5 minutes left in class. Use those 5 minutes to turn in a picture of your notes. All right, everybody should have turned in their notes. Whatever you wrote down during class is what you should take a picture of and submit for your notes, for your classwork grade. I'm going to end the meeting. I hope everybody has a good day.
Bye.
Bye, Hunter. Did you turn in your classwork?
Bye.
Bye, Mara.